Now, last but not least, I am very happy to welcome Röhm, co-founder and CEO of Apheris, who has a diverse academic background in mathematics, medicine, and philosophy, and also has a passion to solve the greatest challenges of our times. This also brings us directly to his topic, data ecosystems. Röhm will discuss recent trends, successes, and challenges of data ecosystems and their orchestration, touching on technologies such as federated machine learning, privacy-enhancing computations, and confidential computing. Röhm, thanks for being here.
Yes, thanks a lot. We are 1 minute early. Maybe we wait until sharp, or what do you think?
I think you can slowly start.
Okay. Then I would share the screen and as such can kick it off. So thank you all for being here. I'm really excited to be here on this conference today, and thanks as well for all the insightful discussions with many of you within these last 2 days. So we are very happy that today's topic is so relevant for many of you. And so what I will be talking about today is how data ecosystems will shape the AI landscape of our decade. And so we'll start by looking at what a data ecosystem actually is, how they are changing our world today, but as well how the future will look like. And we will then look at the 3 core technologies that data ecosystems face, and as well how to overcome them. So let's kick it off. Now, artificial intelligence is a booming technology, and AI usage is transforming every aspect of the modern enterprise. And I think everyone knows that AI is only meaningful if you have enough data. So in this graph here, you see 4 different machine learning algorithms. So that means algorithms with different architectures and inner workings, and all of them are trained on the same natural language processing task. Now, on the horizontal axis, you see the size of the data set. And on the y-axis is the accuracy of the machine learning algorithm. And each of the line represents a different machine learning algorithm. So what we see in this graph is that it basically doesn't matter which algorithm you choose, as long as the data is large enough. And we call this effect the unreasonable effectiveness of data. And it says that size of the data matters far more than the algorithm itself. And that explains why the success of AI applications directly depends on access to the right data. Now, such relevant data for training machine learning models is typically distributed across many different parties. And data sharing between parties or centralizing it is often impossible or harmful for the business. So that means that data scientists today are usually limited to their own proprietary data sets. Now, the reason why companies cannot share their data is because they need to protect the IP of it, but not just the IP of the data, but as well the AI model can be valuable IP. And so whenever you are dealing as well with personal data, the minefield of data protection regulation can be a total barrier for sharing data. And by that, I mean not just giving access to it, but as well receiving such data poses obligations on you. So even in cases where sharing such data would be legal, you'd rather not have it, as you're exposed to rights of individual data subjects you may not be able to comply with. And last but not least, the sharing of data is often not possible because companies cannot trust each other, and so losing control over your data poses a huge risk to the business. Now, collaborative data ecosystems are the alternative to solving exactly that challenge. So the graphic here shows a setup where a number of companies connect some of their proprietary data sets to a joint ecosystem. But the data involved is not shared with the other parties. So as a result, they can jointly draw insights from each other's data. So that's, for example, training a machine learning model. But every data owner and model owner keeps the intellectual property of their data and as well algorithmic assets. Now, all of them benefit here from a huge amount of training data. So remember the graph that I showed in the beginning. And so that means that we get more robust models, often easier to interpret, and as well with higher generalizability. And the benefit here is that the data owners stay always under the full control of their data. And a federated architecture means that data is kept local within isolated and confidential environments. And we bring computations to the data. So that's the idea of a decentralized setup. And as well, typically common and governing frameworks define rules for a given ecosystem to make it valuable, but as well auditable for all parties involved. Now, such collaborative data ecosystems are on the rise across industries, and they are already today revolutionizing how we think about data value and as well how we build data products. And so let's take a quick look at a couple of successful examples. Now, a very prominent example within pharma is the public initiative Melody. So in Melody, many of the largest pharma companies in the world provide their most valuable asset for joint model training. And so that's the data about their own molecules. So what happens then is that drug discovery models are jointly trained on the diverse data of multiple pharma companies. And so these trained models then learn about properties of molecules. And as they've seen so much diverse data, they generalize far better to unseen molecules. And so that's exactly what the pharma companies need to accelerate drug discovery. Similarly, in manufacturing, Musketeer is a data ecosystem where, for example, data from robots is jointly used to train models for predictive maintenance or as well product safety. And so here again, data is not shared between the entities, but each party keeps their data confidential, but nevertheless, they learn jointly from their data. And as well, Gaia-X, which most of you probably have heard about. So Gaia-X is the federated data infrastructure for Europe, and they have multiple use cases where data ecosystems are being developed according to the Gaia-X standards. And so examples here range from data ecosystems between hospitals to data ecosystems between cities or as well financial institutes. And so these here are examples for very large and well-known ecosystems. But maybe even more interesting is that there are numerous examples where private companies started collaborating together on a certain use case and started developing a small data ecosystem out of it. And so what we can be sure of is that the relevance and the value of data ecosystems will increase. And so today, already a vast majority of data analytics professionals know that they need to increase the use of external data sources. And that makes sense in a world where the adoption of AI is accelerating and as well the dependence of data therefore increases. On the other hand, enterprises often gather lots of data, and let's face it, they don't always know what to use it for. And so often there are high value use cases outside of the own organization. So why not just use data and generate revenue with it? However, the more data is generated and the more AI applications are built, the more endangered the personal data of all of us basically is. And so as a result, regulatory barriers will become stricter. And yeah, I think we need to find new ways to ethically use personal data for innovation without putting individuals at risk. And so data ecosystems here will be the key to answer exactly that dilemma. As well, if you think about how COVID-19 accelerated both the need and transition towards global data collaboration. So that's one massive shift that we saw, not just in biomedical R&D, but as well in collaboration across countries, across geographies, or as well organizations. And yeah, so by now, I guess you're convinced that data ecosystems are important and as well will become more important over time. So I think it makes sense to look at what the challenges are to accelerate the transition, and as well how companies can become a thought leader in the data ecosystems that will arise in their industries. And so the three key challenges we need to overcome are: one, we need to break down the complexity. So dealing with such new technological and business concepts is not easy. And so breaking things down into smaller steps is crucial. Then second, we need to enable the full range of data science operations. So what we've seen is technologies that solve only very specific problems. And that makes it hard for industries to learn from each other. And only when we enable real data science, a data ecosystem becomes an alternative to centralized data. And that's not an easy claim. And as well, with Apheris, we are super proud to be working on that very exciting problem. And then third, and most importantly, we need holistic security and privacy frameworks. And that means through combining the right technologies, but as well through combining them with the right policies. And so I would suggest that we take a look at each of those challenges and then understand how to cope with them. So let's start with one. Breaking down the business complexity sounds easy, but is often a big challenge. So here we highly recommend starting small while having a bold vision in mind. And both is really important here. So we've seen data ecosystems not get off the ground because the first step was so complex. But we have as well seen data ecosystems that don't evolve because they were limited around a small use case. And so the combination here is really key. Then coupled to that, choosing the right partners is crucial. So both the technology partners, but as well choosing the first ecosystem partners. And then last but not least, very important is that first ecosystem participants focus on a sustainable business model. So not just for themselves, but obviously as well for future participants that then join the ecosystem. Now, the second big challenge that needs to be tackled is putting data scientists into a position to use the tools they're used to when they analyze distributed data in a privacy-preserving manner. And the closer we will get to that goal, the greater the advantage of data ecosystems will be. And at some point, centralized data will become obsolete. Now, that's a big technical challenge. But to be honest, the technical innovation in privacy-enhancing technologies has been so high that we can clearly say that the core technologies here are not the bottleneck. But what's key is getting the right tools and metadata to the data scientists such that it becomes smooth to do data science on not directly accessible data. So this workflow that you see in this picture shows how data scientists access meta information about the data within the ecosystem. So that means they get basically an environment with virtual data, sample data, and as well meta information about the data that enables them to build their data science workflow. Now, in our platform, we call this the Apheris Integrated Development Environment. And key here is to support the iterative and hypothesis-driven research flow of a data scientist. Now, for enabling data science on distributed data, and so that's not just model fitting, that's actual data science. Now, for that, we can expect lots of product innovation over the upcoming years. And as well, certainly, yeah, you should follow us if you want to stay informed about that, because that's exactly one of our unique selling points with the Apheris platform. Then the third challenge we discuss about today is building a holistic privacy and security framework. And the technological side is one key component for that. And so there's been tremendous innovation in various cryptographic and data privacy technologies. So some examples here are secure multi-party computation. So that's a technique where you jointly compute a function without sharing the raw data between the parties. So these are cryptographic protocols that enable that. Then differential privacy. So differential privacy is, first of all, a very intuitive definition for privacy. And methodologically, we add noise, so statistical noise, to the computation output to ensure that it cannot be tied back to any individual's data in a data set. Then third, privacy-preserving record linkage allows you to link records of so-called vertically distributed data. So that's data where multiple parties have an overlap in their samples, but they capture a different feature space. So I'll give you an example. For example, a genetic lab and a hospital have data about the same patient, but they capture different type of data, obviously. And so what privacy-preserving record linkage allows you is to link such data while preserving the privacy. And then last but not least, homomorphic encryption is a technology where you can compute in the encrypted space. So that means data does not get decrypted during computation. Now, I could be talking on those technologies for a very long time, but what's important here is that one leverages the right combination of such technologies. So these technologies are very complementary. And again, the key here is to enable a data scientist who's not an expert, or not an expert in privacy technologies, to leverage the right approach without needing to become a privacy expert. And if that's done right, and as well coupled to the product innovation that I described before, we see the rise of a new discipline, which I personally couldn't be more excited about. And that's the discipline privacy preserving data science. So again, if all of this is interesting for you, follow us and accept some breakthrough product innovation over the upcoming years in that field. Now, nevertheless, technology alone is not enough to establish a system that's reliable and trustworthy. And so a strong foundation for that trust is as well an architectural setup that is built with all relevant regulatory frameworks in mind. So you need to configure the architecture to provide for compliance and as well auditability. Then on top of that, the adoption of data ecosystems will greatly benefit from rising market standards. And so today, frameworks for data ecosystems are often custom made. And yeah, we as Apheris, we think that this should not be the case. And that's why we partner as well with Gaia-X, because we believe that common rules are critical, and we strongly support such standardized governing policies that provide clearance for everyone, and as well will allow us to learn across industry use cases. Nevertheless, multiple parties with multiple backgrounds have multiple requirements, and all of them need to be addressed to just make things work. And so on top of our setup and the policies, we see customizable legal frameworks for specific requirements. And those are key to get everyone aligned. Now, with Apheris, we've developed a platform for federated and privacy-preserving data science to enable our customers to overcome exactly those business challenges, but as well technological challenges that I described before. And so we help our customers and partners to build and orchestrate collaborative data ecosystems across industries. And the platform is built for data scientists on the one hand, but as well for business executives that need to orchestrate a data ecosystem and then need support on the legal, on the contractual or data governance side. And so with that, I would summarize. So I hope I gave everyone a good overview of how data ecosystems will be key in solving the world's biggest AI challenges. So that's basically through access to diverse data of multiple parties. Now, the core technologies to orchestrate data ecosystems exist, and they grow continuously with further adoption. And so we see this adoption across use cases and industries constantly accelerating already. And so our advice to any data-driven company is to start small today, but have a bold vision in mind and prepare yourself for lots of innovation and disruption in this field. And so if any of those topics we discussed today is interesting for you, feel free to reach out to me, and happy to proceed with a conversation. Here's my mail as well. Or as well, hop on our company profile here at the event and register for our new newsletter. And with that, I would like to thank everyone for joining the session today. So we're super excited to be part of this fantastic community. Thanks a lot for the great discussions and insights. And so if there's time, I'm happy to take any questions. Thank you.
Thank you very much, Robin. I'll take this chance for one last question. On-device machine learning holds the promise of achieving higher levels of privacy for users. Are there certain use cases where you believe on-device machine learning does not make sense?
So I mean, first of all, I do think that on-device machine learning makes sense for some use cases. I think nevertheless, in particular for highly computational tasks, access to compute is critical. And so, for example, for image analysis, I would say, so for example, medical image analysis, I think you need access to compute. And so it makes sense that this is either in a cloud, obviously here an isolated and confidential environment, or as well on-prem, but with access to compute. And so that's just one example. So for any high resource intensive task, we would nevertheless recommend a distributed setup, but not on-device machine learning. And so what I discussed about today on the most data ecosystems that we see today are not primarily on-device. Some parts of it might be on-device, but a key of the computation happens either on-prem or in the cloud, but decentralized.
Thank you very much, Robin, for closing this stage today and for the interesting presentation. So at the Grace Hopper stage, our program is over. Thank you for being part of the Big-Data.AI Summit, the first digital one. If you want, you are cordially invited to join the Harry Seldon stage for the last program items. Thank you very much.